clearing the malignancy.
This whole video is going to be about zinc playing a critical role in a lot of the things that I've been talking about in my previous videos. So with calcineurin, also with oxysterol, whether if they can load up or not, because oxysterol
Lysosomes support poly-A tail elongation on CD70 through immune signaling.
Have to do with exosome formation and release. Once that happens, exosomes can cause a lot of problems, even irreversible. So first one here, ABCA1 is zinc dependent, and the mechanism of this protein is ABCA1 is a large ATP binding cassette transporter with multiple cytosolic nucleotide binding domains. So zinc contributes in three ways: structural stabilization, by coordinating histidine and cysteine residues in cytosolic loops. This prevents misfolding. Okay, so what oxysterols will try to do, plus or with reactive oxygen species, is to oxidize thiols on ABCA1. But zinc shields these residues, which are the thiols, by stabilizing thiol geometry and supporting antioxidant enzyme systems. Also, extends ABCA1 half-life at the plasma membrane. Now, that might have something to do with the lysosome, the MVB fusing to the lysosome instead of MVB fusing onto the plasma membrane. Because if MVB fuses onto the plasma membrane, then that's how exosomes are released and exosomes are able to do their damage. Okay, so without zinc, ABCA1 is sent to lysosomes for degradation. It's not good, because then that means that ABCA1 cannot transfer cholesterols and oxysterols to APA1 or nascent HDL. So basically the functional consequences are oxysterol accumulation in MVB sacs, which is a good thing, which is also one of the main goals or targets of my videos associated with oxysterols and exosomes. But that won't happen if ABCA1 is sent to the lysosome for degradation as a result of zinc deficiency, which is why it's important to make sure to not have excessive copper, because excessive copper will end up reducing zinc, and then there won't be enough zinc for this oxysterol reduction process. Okay, so since ABCA1, the biological goal is to detox, and it's not just lipid export. Also, ABCA1 functional consequences: reduced ESCRT-driven ILV loading. So basically, ABCA1 prevents the loading, possibly oxysterols, onto the ILV, or the vesicles grabbing onto the oxysterols. Also, ABCA1, if it's functioning with the zinc, reduces exosomal oxysterol release, which is good, because oxysterols themselves, they form MVBs so that exosomes can be formed, so that the exosomes can continue to release oxysterols, so that the oxysterols forms the MVBs that loads the oxysterols. Therefore, it seems like a self-reinforcing feedback loop. Okay, so zinc deficiency means ABCA1 destabilized, means oxysterols remain in MVBs, which is not a good thing. Increased ILV loading or lysosomal overload, more inflammatory exosome signaling. So all of that is a result of the zinc deficiency. Zinc is also critical and important for calcium influx for calcineurin signaling. Okay, so an adequate zinc leads to clean pulsatile calcium release. Zinc deficiency, blunted or erratic calcium flux, which is not good because that means that the calcineurin is not going to do its roles correctly. Because zinc deficiency means more reactive oxygen species, therefore oxidation of the TRPML1 channel. So basically that's like the gate or the channel that controls the flux of calcium, and that will be impaired with zinc deficiency. Okay, so when TRPML1 opens, lysosomal calcium microdomains form. This is important to activate calcineurin. And the actions of calcineurin dephosphorylates NFAT, or calcineurin removes phosphate groups from NFAT. Therefore, NFAT can translocate to the nucleus so that it works towards IL-2 replenishment for exhausted T cells. But this calcineurin process cannot, or at least for IL-2, cannot work without AP1 C-Jun FOS. So the consequences of zinc deficiency means reduced or down-regulated TRPML1 calcium release, therefore reducing calcineurin activation. Therefore, persistent phosphorylation of NFAT and AP1. Also, AP1 loss is the result of ongoing CD70 on the tumor and then CD27 on the immune cell. Therefore, NFKB is consistent, eventually leading to AP1 loss, and then immune cells are inactivated. But calcineurin removing phosphate groups from NFAT, the goal is to reactivate and revive T cells with IL-2. But of course, that process also cannot work if zinc is deficient and if AP1 is still lost. So AP1 can still be lost even after, with adequate zinc, enabling calcineurin to remove phosphate groups from NFAT, which is important to replenish IL-2 for T cells. The lack of calcineurin as a result of zinc deficiency also reduces lysosomal biogenesis, which could imply, or which could mean, that lysosomes will not be able to help in the clearance or in the prevention of exosomes. Because MVB, if they're loaded with exosomes, have to fuse to the lysosome to change the cargo load fate, or the cargo would be the exosomes. But if there are no lysosomes, because of reduced lysosomal biogenesis as a result of zinc deficiency and no calcineurin, then that means that the exosome will probably be released because the MVBs won't have the lysosomes to fuse to. The lysosomes will be missing, and then the MVBs will have to fuse to the plasma membrane, which is not wanted, which is what is the goal is to stop that from happening. Because if MVBs fuse to the plasma membrane, then the exosomes will be released to wreak their havoc and their damage. Okay, so quick recap. ABCA1 is zinc dependent. If zinc is deficient, ABCA1 becomes sent to lysosomes for degradation, which isn't good because then oxysterol will accumulate in MVB sacs, which is to be avoided. Okay, zinc deficiency means ABCA1 destabilized, oxysterols remain in MVBs, therefore leading to more inflammatory exosome signaling. Okay. TRPML1 is a zinc-dependent channel. Also, calcium relies on zinc for calcineurin signaling. Okay. Zinc deficiency means blunted or erratic calcium flux, meaning no calcineurin to remove phosphate groups from NFAT, therefore no IL-2 replenishment for exhausted T cells. Also, no lysosomes for the MVB to fuse to instead of fusing to the plasma membrane. So that's it for the video. Like, comment, share, subscribe, and I'll see you in the next video.